Hey guys, today we're on analysis unit 10, lesson 2. We're first going to be discussing some limit properties, and then we're going to be talking about how we can evaluate limits using direct substitution. So if you want to just kind of recap from yesterday, the notation for a limit. The limit as x approaches c of f of x equals L, where L is just a y value. Remember, and you're going to find that I kind of put this little graph on every day. Basically, when we're talking about a limit, we're talking about a limit as x gets close to, but remains unequal to some value c. Our y values on our graph are getting close to some number L. Okay. We talked about evaluating limits yesterday using the table method, reading, talking about what's happening from our y values on our table. We talked about how to evaluate a limit by looking at the graph of a function yesterday. Okay, today we're going to get a little bit more technical with the notation. It's going to be confusing at first, but I promise you it will start to make sense. All right, so our basic limit properties. The limit as x approaches c of a is just going to equal a. The limit as x approaches c of x is going to equal c, because we're just plugging in c for x. And again, it will start to make more sense in just a few minutes. The limit as x approaches c of b times f of x. If we have a situation like this, we can move our b out front and then evaluate the limit. If we're adding more than one term together, we can break apart our limits. If we're multiplying more than one term together or more than one function, we can break apart and multiply their limits. And same holds true for division, provided the limit of the denominator does not equal 0. Now, this looks extremely complicated and scary, but it's not, okay? If we look at an example, the limit as x approaches c of f of x equals L. The limit as x approaches c of some function g of x equals m. We're going to use our properties to find each of the following limits in terms of L and M. So I'm going to first just break this apart using my properties. This just means the same as this. And the limit as x approaches c, this is just L, and this is just M. That's your answer. Using that same approach, the limit as x approaches c, now I have 3 times f of x, so I'm just going to bring this 3 out front. And I'm going to bring that 3 out front, and that 2. Now I have 3. This is equal to L minus 2, and the limit times M. Again, we're just applying our properties. Here I have a multiplier. I'm going to move that out front. The limit as x approaches c of f of x times the limit as x approaches c of g of x. 4 times L times M equals 4LM. I know this seems a little bit weird, but it's not that difficult to do. We can also use our properties to find from the graph of a function. All right. So now this time we're looking at the graph of f of x and the graph of g of x. So we're going to use their function, their values. I have the limit as x approaches c of 2 times f of x. So this is 2 times the limit as x approaches c over the limit as x approaches c of g of x. Well, what is the limit as x approaches c? And that C should be, let's make it a 2. I'm sorry. We're going to do this, the limit as x approaches 2. So that's how the original problem should read. So our C value is 2. So the limit as x approaches 2 of f of x is 2. And the limit as x approaches 2 of g of x is -1. So our answer is -4. In our next example, again, we're going to use 2. I'm just going to rewrite this problem. Okay, so using our properties, the limit as x approaches 2 of 4 times f of x would be 4 times the limit as x approaches 2 of f of x minus 3 times the limit as x approaches 2 of g of x. Well, what is the limit as x approaches 2 of f of x? We're going to go back up to our function f, that was 2. And the limit as x approaches 2 of g of x is -1. So 8 plus 3, that answer is going to be 11. So if you haven't kind of already noticed, evaluating limits is just like evaluating a function. Okay? And that's what we're going to do in our next section. Okay, so now here's where things are going to start to make more sense. Finding limits using direct substitution. So yesterday we talked about how we can find limits by using a table or just by looking at the graph. Okay. Today, right now, our focus is going to be on a much easier method called substitution. In this method, we're just going to simply plug in whatever x is approaching. I want to, before we begin, just refresh our memory on our 2 basic properties that help us here. The limit as x approaches c of some number a is just a, and the limit as x approaches c of x is going to be c. And we're going to evaluate each of the following limits. So the limit as x approaches 3 of 5, well, since 5 is just a number, it's just going to be 5. And I want to stop here for one moment and just discuss, think about this. This function is really just the horizontal line y equals 5. Whatever number we plug in, we're going to get 5. Okay. So when you're taking the limit of a constant, it's going to be whatever that number is. The limit as x approaches -20 of 5. Well, again, think about it. If I plug in -20, what am I going to get as my answer? 5. The limit as x approaches 3 of x. Now remember, by direct substitution, we're simply substituting in our value, and we're going to get 3. The limit as x approaches -4. -4. The limit as x approaches 0 of -8. That's going to be -8 because it has no x with it. So it's just going to be whatever the number is. The limit as x approaches -3 of x plus 4. Okay. Again, I'm going to stop for a moment. We're not going to do this, but technically, this is really using our properties. It would be -3 of x plus the limit as x approaches -3 of 4. But do we really have to do that? No, we can simply just plug into the function. And that's why evaluating limits is so easy. The limit as x approaches -5, remember, just plug in. -4 times -5 equals 20. The limit as x approaches 2. Okay, now remember, using your properties, you would do each one, but you don't have to do that. Just plug in. 5 times 2 to the 4th minus 6 times 2 cubed plus 3 times 2 squared plus 4 times 2 minus 2. Work out that math. Take a minute or two. When all is said and done, you should get 50 for your answer. Any function that we can evaluate, we can now include limits. So a square root, that's not a big deal. The limit as x approaches 0, I'm going to replace 0 for x, and I get the square root of 8, which is 2 rad 2. The limit as x approaches 3, I'm plugging in 3 for x. 3 squared minus 3 minus 6, 3 plus 3. 9 minus 3, so 9 minus 3, that's going to be 6. 0 over 6, which is 0. The limit as x approaches pi over 2. We can plug into trig functions because we know how to evaluate them. So I get pi over 2 plus the cosine of pi over 2. Well, what is the cosine of pi over 2? 0. Pi over 2 plus 0. My answer here is pi over 2. Remember though, this answer, when it stands alone like this, now it's a number. Okay, so this is really 3.14 divided by 2. This is not an angle measure. And in our last example, number 12, the limit as x approaches 0. I'm going to plug in 0 for x. E to the 0 is just 1, so I have 2 times 1, and my answer is 2. So even though some of the things we've talked about may seem a little bit confusing, just remember, for the majority of this unit, okay, we're now getting to the part where we're just going to be plugging in. Okay. Things are going to start to kind of connect and make more sense at this point. All right. Thanks, guys. Do your homework, and we'll see you soon.